and you were in 8th grade, I would start with super easy examples, and I'd probably do 15 of them. At this point, I would assume you know the basics of factoring by GCF, so we, bump up to little tougher ones right off the bat. So you want to look, obviously, first at your coefficients, a 10 and a 5. What's the biggest number I can take out of both of those? 5. So I put that way out in front. And then you also want to look at your variables. You have an x squared and an x. So how many x's can I take out? Just one, right? I can't take out 2 because this doesn't have 2 to give. I really can only take out whatever the smaller exponent is, a 2 versus a 1. I can only take out the smaller amount. So x to the first power. Now, can someone tell me a synonym for factor? No. Factoring and distributing are actually opposites. Those would be antonyms. Just to bring a little English class into this. So factoring and distributing are antonyms, opposites. Okay? So let me go with that then. I'll use that to your advantage. What is a synonym for distribute? What operation? Do you know what operations are in math? Add, subtract, multiply, or divide, right? Those are operation options. So distribute is multiply. And so factoring, which is the opposite, factoring must be division. Okay? So when we are factoring out a 5x, see, are you with me over there? You're dividing out a 5x from each term to see what's left of them. Now, in a basic example, I know a lot of you can do this in your head. You wouldn't have to do this. But if you need help kind of organizing yourself, you can literally show divide by 5x to see what's left of that. And 10 divided by 5 is 2. X squared divided by x is x. That's technically, believe it or not, an exponent rule. Dividing common bases, you subtract the exponents. I know you guys would get this without thinking about it in that context, but that is what's technically going on. And when you divide this term by 5x, what do you get? What's 5x divided by 5x? 1. Maybe not a strategy you want to use on something that simple because you just flat out don't have to. That's second nature. But maybe over here, I would think otherwise. Okay? So, look at your coefficients, -8, -12, and 2. Angie, what can be divided out? What number can be divided out of all of those?
2.
Good? Is that the biggest one? It is. Here's a rule. Anytime something leads with a negative, you usually take out the negative version of that number. So we're actually going to divide out a -2. Now move off of your numbers to your variables, starting with the x. We have an x cubed, an x squared, and an x to the 9th. Mike, how many x's can I take out? 2. Very good. The smallest of those exponents, 3, 2, and 9, is 2. And then move to your y's. So y to the 5th, y to the 7th, y to the 3rd. Natalie, I can take out what? Y to the 3rd, right? And then, for the record, if it's a trinomial to start 3 terms, then you should have 3 terms left. We have 3 little division problems to tackle here. Now, you can write this divided under each term if it helps you, or you can just think about it. What's a -8 divided by a -2? What's x cubed divided by x squared? And what's y to the 5th divided by y cubed? Beautiful. So there's your first term. Next term. What's a -12 divided by a -2? +6. What's an x squared divided by an x squared? Gonzo, right? If it's a 1, you don't have to write it because 6 times 1 would just be 6. And what's y to the 7th divided by y to the 3rd? Beautiful. And what is 2 divided by -2? -1. X to the 9th divided by x squared. And y to the 3rd divided by y to the 3rd? I'm done. Because I don't need to write that 1. Any questions? This one should look totally weird to you. Does it? Maybe? Who thinks they know what to do here? Bella?
Distribute 2x and 3 throughout like parentheses and then factor it.
Nope. Good try though. We don't, I mean it might work. It might work. We don't want to distribute though if there's a way to avoid it, because that's doing the opposite of what they're telling us. They're telling us to factor. Let me back up. How many terms do you see here? It's a little bit of a tougher question. Here there were 1, 2, 3 terms. I'm going to tell you how many you should see. You should perceive this as 2 terms. Here's the first, plus here's the second. I know each of those terms is kind of complicated in and of itself, but you should see that as 2 terms. It's a binomial. Something plus something else. Albeit it's complicated plus something else fairly complicated. What do both of these pieces have in common? Jason? They both contain what? Yeah, what about each of those matches? They both contain a binomial. What is that? What's the binomial that this contains and this contains? X minus 7. You see it now?
Yeah.
They both have an x minus 7. Awesome. Pull that out in front. Now, because that's a binomial, we're going to put it in its own set of parentheses. Now, when you divide this first term by x minus 7, what's left? 2x. When you divide this second term by x minus 7, what's left? Plus 3. Done. Okay? You almost have to train your mind to see it for that. I do realize you guys are very much like, oh my God, let me distribute. You see something in front of parentheses and you don't know what else to do, you just distribute because it's easier. Now, that being said, Bella, I think that probably would have worked, because if you would distribute, and you guys don't write this down, you would have gotten 2x squared minus 14x plus 3x minus 21, and you would have combined like terms like this. But then your factoring method wouldn't be just a basic GCF. It would go back to that kind of guessing and checking that we did in previous factors, right? X times 2x is 2x squared. The outer is 3x. The inner is minus 14. 3 minus 14 gives us the negative 11. And negative 7 times 3 is negative 21. So could you get there? Yes. But doesn't that make your life so much harder? If you had just seen the x minus 7, aren't you there just so much faster? A lot less thinking. Try this one on your own. You can try the next 3 on your own if you'd like. Chloe, have you done that on the back? Does that look familiar? Okay, good. Well, sort of good. Oh boy, where are we at? Kate, what'd you get for the first one here? I'm sorry, I was rolling my chair and I couldn't hear you. Go again. What x minus 2? Anybody get anything different? Perfect. Next one. What did you get? Chris Brooks.
7 CD.
E minus 2?
Yeah.
Did anybody get anything different? Uh-oh, Chris. Alexa? 7DE parentheses, say that again. Did anybody get anything different than that? All right, so, Chris, do you see what you did wrong?
No.
So if you look, your 7 was right. You took out a C when this one didn't have a C to give. You had a C here, you don't have a C here. So there's no overlap, so you can't take that out. Follow? You took out a D, which was correct. You took out 1. What you didn't take out was the E, and they did have an E that could be taken out. So you look at your number 714, it's a 7. You look at your C's, they don't have an overlap, can't take that out. You look at your D's, they have D as an overlap, you can take that out. You look at your E's, they have an E as an overlap. So when you take out your 7, one of the D's, and an E from this, you're left with CD. When you take out your 7, your D, your E, you're just left with 2. Good? And the last one, Faye. Just 5x? Okay. You broke my rule that if it starts as a binomial, your parentheses still need to be a binomial. So you divided your 3x squared out, great, and got 5x. You didn't do 3x squared divided by 3x squared. What would that be? Plus 1, yep. So that's how you kind of maintain that binomial. Because if you're checking your factoring, if you went to distribute and you just had 3x squared times 5x and you were checking the multiplication to see if it gets you back to the original, you would go to multiply and you'd only get 15x cubed. You'd be missing that other term. So you need that 1 so that when you check your distribution, you have that. Okay, the back should look brand new to you. When you have 4 terms, or 6 terms, or an even number of terms, there's something called grouping. Raise your hand if you've ever heard of grouping. Okay? So, all right, so we're all starting from square one, and we're just starting off with 4-term cases today. Grouping is essentially doing the GCF 3 times in a row. But not the GCF for the entire problem, because quite frankly, there isn't one, is there? Do all 4 of these have anything in common? No. So when you're grouping, what you do is you mentally group the first 2. What's the GCF of those 2? Eric? X squared. And when I take out an x squared, Eric, what's left? Perfect. And then you do a second GCF problem by looking at the second group. What GCF do those have? Tess? And is it a positive 4 or a negative 4? What is in front of the 4? So that's what you're going to say. It's a positive 4. I only stress that because you have to write down a plus here. Plus 4 times, and Tess, when you divide out that 4 from those, what's left? Perfect. Now, I said that grouping was GCF 3 times. We've done 2 of the 3. Here's how I know grouping worked. Those parentheses match. Sometimes you might try grouping and your parentheses don't match, so then grouping wasn't possible. Okay? But if they match, now it becomes a problem just like this one on the front, where we said, oh, what do they have in common? An x minus 7. So we take that out in front. What do these 2 have in common? x minus 3. So we take that out in front. It's a binomial. Keep it locked up. And what's left? X squared is left from the first piece, and a positive 4 is left from the second piece. We're done. There's my GCF 3 times. Get it? Got it? Good. Okay, look at the next one. Group the first two. Angie, what can you take out? Well, if you look at this is technically what number out in front? A 1 and a 6. What's the GCF of 1 and 6? Right, so you don't really take out a 1 usually. Okay? And then you move on to your x's. We've got an x cubed and an x squared, so how many can you take out? X squared, good. So when I take out an x squared, Angie, what's left? Plus 6, perfect. Second group. Negative 2x minus 12, Bella, what can I take out? 2. Negative 2, does everyone see that? It leads with a negative, take out the negative. So negative 2, and what's left, Bella? X plus 6. Did grouping work? Yes, how did you know? They match, so I take that x plus 6 out in front. And what's left, Corey?
X squared minus 2.
Beautiful. Not hard, right? Just different and weird. Last one, because I like to throw multiple variables at you. There's another thing I got to talk about in this one too. Look at your first group. Chloe, what can I take out?
X.
X, and what's left?
X plus 3y.
Beautiful. Second group. What can I take out? Georgia's shaking her head. Nothing, right? So here's the deal with a grouping problem. If you don't think you can take anything out, and she's right, you really can't, you have to take out a 1, okay? So, and because this is a positive, we're going to take out a positive 1, which really isn't going to change anything. Did grouping work? Did these match? No. Cross it off. However, sometimes grouping doesn't work because of the order it's currently in. If you were to maybe flip-flop those two middle terms, so let me rewrite this. X squared plus 3x cubed plus 3xy plus y. Let's try it just reordered. What can I now take out of the first two? Elena?
X squared.
X squared, and what am I left with?
X.
Not x. What's x squared divided out in x squared? 1 plus 3x. Just 3x, right?
Yeah.
Olivia, second one, what can I take out? Plus y, what am I left with? No. 3xy divided by y is 3x. Y divided by y is, right? Do those match? Is 1 plus 3x the same as 3x plus 1? Absolutely. So take it out in front. I don't care which way you write it. Probably the more traditional way would be 3x plus 1. And I'm left with x squared plus y. So when you add more variables, it gets a little bit more tricky just because you got to think on each individual term a little bit harder, okay? So the worksheet I'm giving you is the same worksheet we're going to have homework off of for the next 5 nights, okay? So tonight's homework is just 1 through 16, all of them. You're not doing them on this worksheet. Number 1, there's no room. Number 2, you need to hold on to this. So when I collect it, I don't want you to hand me this, right? So on a separate sheet of paper for the next 5 nights, and do not lose this worksheet because we're going to reference it over and over and over again. Okie doke. It's been a pleasure doing business with you. I'm almost done grading your tests. Everyone was here yesterday, so I should have them back to you tomorrow. It was a harder test. I told some people this morning, I give you Common Core questions all year long. So some tests will be like, ooh, ouch, but that just gets you ready for your exam. Andy, were you want to work?